And we're going to start with this problem and see if we can work this out. Let's see, did anybody come up with an answer? Okay, somebody came up with C. I happen to agree that C is the right answer. Let's see how we work this out. So here's my problem. Remember, when we're adding or subtracting of radicals, we can only add and subtract like radicals. So here's my -4 radical 2 minus radical 49 minus 6 radical 18. If I'm looking at this starting out, it doesn't look like there's anything to combine because this is a 2 in the radical, this is a 49, this is an 18. None of them are the same. However, we're going to simplify our radicals and then look back. So this has a 2 in here. We can't simplify this anymore, so this becomes 4 radical 2. 49 happens to be a perfect square. The square root of 49 is just plain 7, so we can take it out of the radical. And the square root of 18 could be broken down into 9 and 2 because remember, when you're simplifying a radical, if it's not a perfect square, you try to break it up into factors that one of them is a perfect square, and the square root of 9 happens to be 3. Don't forget, when you have a number outside a radical, you can't multiply a number outside a radical with a number inside. But now that I've simplified this, this 3 is no longer inside the radical, so I can now multiply this -6 times this 3. So that will give me -18 radical 2. Remember, this means multiplication. It's not addition because you have them right next to each other. You can't see the rest of A. So now we have -4 radical 2 minus 7 minus 18 radical 2. Now the -4 and the 8 radical 2 and the -18 radical 2, those are like radicals. So I can combine the -4 and the -18, which gives me -22 radical 2 and minus 7. Now I cannot combine the 7 with the -22 because the 7 doesn't have any radical 2 next to it. In other words, this is your answer in the simplest form, which is choice C. Any question about that? Okay. Let's try one more example of something that we learned on Tuesday. This was simplifying. This is about simplifying radicals and adding, subtracting. What happens if I want to multiply radicals? So let's try an example like that. Suppose I gave you this example. 5 minus 3 radical 2 times 4 plus 7 radical 2. Suppose I asked you to multiply these two binomials. These each individually cannot be simplified more because they're not like radicals, but they are each 2 terms. See if you could multiply those together and come up with an answer in simplest form. I'm going to give you a couple minutes to try that. Since these are 2 binomials, when we multiply them, we're going to be using FOIL. First, outer, inner, last. So first, 5 times 4 just gives me 20. Then outer, the 5 times the 7 radical 2. Now, since the 5 is not in a radical, I'm going to multiply by the 7, which is outside the radical. That'll give me 35. And just bring down the radical 2 because there's no radical here to multiply by. Then I do inner, negative 3 radical 2 times 4. So the negative 3 and the 4 can be multiplied together, which will give me negative 12, and bring across the radical 2. And finally, we have last, negative 3 radical 2 times positive 7 radical 2. So the negative 3 times the 7 is negative 21. And radical 2 times radical 2 gives us just plain 2. Remember a special rule. The square root of x times the square root of x always just gives me x. When you multiply a radical by itself, it just removes the radical. You're just left with what's inside the radical. Which means that this is now a 21 times a 2, which is a 42. And now I can combine the like terms. There's a positive 20 and a negative 42 that are not attached to any radicals, so those are like terms. 20 minus 42 is negative 22. And then we have a 35 radical 2 minus a 12 radical 2. So 35 minus 12 is 23 radical 2. And don't combine the negative 22 and the 23 because they're not like radicals. Your answer is a binomial with two terms, negative 22 and plus 23 radical 2. So that's how, if you remember, how we multiply radicals. Just let's do one more like this. Do another multiplication. Suppose I gave you 6 minus radical 3 times 6 plus radical 3. What if I gave you these two binomials, which if you recall are called conjugate binomials because they really look identical, except one has a minus in it and one has a plus. Let's see what happens when you multiply those two together. I'll give you a couple of minutes for that.
I have a question.
Yeah, sure.
For the question beforehand, is the 42 negative?
Yes, because it was here. This is a negative 42 because it was a negative 3 times a positive 7, which gave us a negative 21. And the radical 2 times radical 2 gave us plain 2. And negative 21 times 2 is negative 42. Is that clear?
Yes.
Okay. All right. So now we're doing this example. Okay, let's see if we can do this one now. Let's see if that comes out to be the right answer. Again, we're going to do it using FOIL. First, 6 times 6 is 36. Outer is 6 times radical 3, which is plus 6 radical 3. inner is negative radical 3 times 6, so that's a negative 6 radical 3. Notice you're not multiplying the 3 and the 6 because one is inside a radical and one is outside. However, we usually put the outside number first because you want to make that, that's how things look. That's a standard way of writing it. Your number that's outside the radical and then your radical. And finally, negative square root of 3 times positive square root of 3. So the negative times the positive is negative. And whenever we multiply a radical by itself, we just get the number inside the radical without the radical itself. Now, if you notice, the 6 radical 3 and the negative 6 radical 3 just cancel each other out. So all I'm left with is 36 minus 3, which is 33. Yes, Jessica, that is the correct answer. And I want to mention that you should notice something. Number one, when we multiply conjugate binomials that have radicals in it, my final answer does not have any radical. I had two binomials, I had square roots of 3, but my final answer was just a plain 33. It's a rational number. That's number one. And number two, what we could have noticed is whenever you multiply conjugate binomials, the outer term always cancels out with the inner term because they're always going to be the same thing, except one's going to be positive and one's going to be negative, which means if I realize that I have conjugate binomials, then I don't have to go to the trouble of doing the whole FOIL. I can just do the first 6 times 6, which is 36, and the last negative square root of 3 times positive square root of 3, which is just plain negative 3, and right away give you your 33. I think we've mentioned this before, that when we multiply conjugate binomials, it's in one place where we don't have to actually go to the whole FOIL. We could just do first and last because we know the pattern. We know that in the conjugate binomials, the outer and the inners always cancel each other out. So this is two important facts that it's important to know. We're going to see how it's going to be useful as we go along. So that takes us to the point where we had left off on Tuesday. We had discussed how to simplify a radical. We discussed how to add and subtract radicals. We discussed how to multiply radicals. So now we're going into what happens if we want to divide radicals. And really, when we talk about dividing radicals, what we mean is, what do we do when we have fractions with radicals? Because usually, let's say if I want to do a regular number, 5 divided by 3, I could just do 5 over 3. It means it's a fraction. So basically, fractions and division go hand in hand. So we're going to do this in 2 steps. We're first going to discuss what happens when I have monomials in both numerator and denominator. And then we're going to talk about what happens if we have a binomial. So let's say I have the square root of 3 over 8. Let's say I have a fraction in a radical. How are we going to simplify it? What do they want when they tell me to simplify it? So the first thing I want to do when I have a fraction in a radical is to separate it, to put it as the square root of 3 over the square root of 8. In other words, when you have a fraction in a radical, it means that both the numerator and the denominator are inside the radical. They are both being square rooted. Now, what we could do is simplify each of the new radicals, the square root of 3 and the square root of 8. Now, the square root of 3, there's nothing to do. It's as simple as you can. You can't break 3 down to get it into a smaller number. It's just 3 times 1. But the square root of 8 can be broken down into the square root of 4 and the square root of 2. And we know that the square root of 4 is 2. So that the answer I'm getting is the square root of 3 over 2 radical 2. Now you would think that this should be your answer because we've simplified as much as we can. But it turns out when they talk about simplifying a fraction or simplifying something where you're dividing, in this case I'm dividing the square root of 3 by the square root of 8, you don't want to be left with a radical in the denominator. You want to do something that's called rationalize the denominator. Rationalize means make the denominator, be sure to end your problem by making sure your denominator is a rational number. A rational number is a number that doesn't have a radical in it. It's just a regular number, a regular fraction or a regular decimal. It's not something inside a radical. And what we usually do after we have simplified this, if there is a radical in the denominator, we multiply the numerator and denominator by that radical. I'm going to multiply, in this case, the numerator and denominator by radical 2. Now, why am I going to do that? Because if you look at the denominator, when I multiply the radical 2 times the radical 2, we know when we multiply a radical by itself, we've been saying that a few times, that just gives us the number inside the radical. So this part becomes just 2. Now remember, I had a 2 over here from before, so 2 times 2, my denominator turns out to be 4. The numerator, I know the square root of 3 times the square root of 2 is the square root of 6. And this is the proper answer to that problem because my denominator does not have any radical. We have rationalized the denominator. The only place we can have a radical is in the top in the numerator. So that's how we take care of a problem that has a radical in the denominator. Okay, let's see if you could do a problem. What if I gave you this one? Simplify, this was number 1. Here's some, I'm going to give you one to try. Suppose I asked you to simplify 3 over the square root of 7. See if you can simplify that. See what you can come up with when you do that one. I'm going to give you a few minutes while I take attendance. Unpause the recording. Okay. There's nothing, first of all, it's not a fraction inside a radical, so I'm not going to separate it. It's already separated. And obviously the only problem that I have here, it looks pretty simple, but I have a radical in my denominator, so I'm going to have to multiply the numerator and denominator of the radical by radical 7, of this fraction by radical 7, because we want to make sure that the number in the denominator turns out to be a rational number. And therefore we multiply it by the radical itself. Radical 7 times radical 7 gives me just plain 7, and the numerator becomes 3 radical 7 over 7. So that's how we deal with an example where we have a radical in the denominator. We want to make sure, especially when the term says simplify, when it says simplify, do not leave, even though your thing looks pretty simple, simplified means there cannot be any radical in the denominator. Sometimes the term's used as rationalize the denominator. Sometimes it just says simplify the fraction. But basically, our whole point is to get rid of the radical in the denominator. Okay, so this takes care of what happens when we have a radical in the denominator and my denominator is a single term. Let's do another type of problem that also has radicals in the denominator, except in this case, my denominator happens to be a binomial. In other words, what should I do if I have something like the square root of 2 over 5 minus radical 3? Again, I have a fraction. The radicals are pretty simple. I can't simplify radical 2. I can't simplify radical 3. But yet I cannot leave the answer like this because I'm left with a radical in the denominator and I want to rationalize my denominator. Make sure that the denominator is just a single simple number, not anything that has radicals in it. Now, I want you to listen and not take notes for a minute. And then we're going to go back and because I'm going to do this and the way I'm doing it is going to be wrong. And then I'm going to go back and do it the right way. You might think that what we should do is multiply the top and bottom of this fraction by radical 3. I have a radical 3 in the denominator, so I want to get rid of the radical 3. I'll multiply by radical 3. And of course, whatever I do to the denominator, I'm going to have to do the same thing to the numerator. Let's see what happens when I do that. In the numerator, I have radical 2 times radical 3. Both the 2 and 3 are inside the radical, so they get multiplied together, and they give me radical 6. And I can't even simplify radical 6 because you can't break it up into a number, one of the numbers being a perfect square. What happens when I multiply the denominator? Well, this is a binomial and this is a monomial. Remember, when you multiply a binomial by a monomial, you have to use the distributive property. So you will get 5 times radical 3, which is 5 radical 3, minus radical 3 times radical 3. Well, radical 3 times radical 3 we know is just plain 3. But if I look at my answer here, it hasn't solved my problem. My denominator is not a rational number. I have not rationalized this denominator because I still have a square root of 3 in my denominator. So the method I used, which seemed to make so much sense, is obviously wrong. So let's see what method could we use that will rationalize this denominator. So I'm going to remind you that what we said is whenever we multiply a binomial by its conjugate binomial, we get just the first and the last. And when we had radicals in it, we saw that we get just a plain number. Remember, we got that answer that was plain 33. We multiplied, both of the examples had radicals in them, both binomials, but when I multiplied them, I ended up with a single rational number of 33. Well, that's what I'm going to do over here. If my denominator of my fraction is a binomial with a radical, to rationalize that denominator, multiply by the conjugate. Now, what's the conjugate of 5 minus radical 3? That's going to be 5 plus radical 3. Conjugate binomials are identical binomials, except one has a minus and one has a plus. If this one would have had a plus, then this one would have had to have the minus. They have to have opposite signs. Now, whatever I do to my denominator, I'm going to have to do the same thing to the numerator. So therefore, I'm going to multiply not only the denominator by 5 plus radical 3, I'm going to multiply the numerator by 5 plus radical 3 as well. Notice this fraction, this whole fraction is just 1, because if you have something on top of itself, like 6 over 6, That's 1. In other words, I'm multiplying the fraction by 1, which means I'm not changing its value. Okay, so now let's actually do this multiplication. Remember, when we're multiplying fractions, we multiply the numerators together and we multiply the denominators together. Now, usually we would do the numerators, but I want to do the denominators first because I remember when I multiply conjugates, I only have to do first times first. So 5 times 5 will give me 25. And last times last. Negative square root of 3 times positive square root of 3 is just negative 3. Because the square root of 3 times the square root of 3 is just 3. In other words, my denominator turns out to be 25 minus 3, which are both rational numbers, and they could be reduced. They could be combined to 25 minus 3, which is just 22. In other words, the denominator will come out to be the rational number 22, no radical. Well, what about the numerator? Well, now I have to multiply radical 2 times 5 plus radical 3. And this is a monomial and this is a binomial. To multiply, I have to use distributive property. So first I multiply radical 2 times 5, which gives me 5 radical 2. Remember, I told you put the whole number first and the radical second. And then radical 2 times radical 3, since these are both inside radicals, I multiply them together. And my final answer then comes out to be 5 radical 2 plus radical 6 all over 22. Now you're going to say, well, that doesn't look any simpler than what it started out with. It's understood simplification means number in the denominator has to be a rational number. It's another way. So this is called either simplifying or rationalizing the denominator. But notice what we did. The denominator to be just a plain regular old-fashioned number like we use on a regular basis. If you wanted to, you could have also separated this and written it as 5 radical 2 over 22 plus radical 6 over 22. Sometimes we write it this way, sometimes we write it this way. I think this is the preferable answer, but this is also a correct answer. And I'm pointing this out because if you're doing a multiple choice test and you see this answer, don't automatically think it's wrong. It is correct. It's as correct as this answer. Sometimes we keep the whole thing over the denominator. Sometimes we separate each of the terms and put them separately over the denominator. They're both equally correct answers. Okay, so now I'm going to give you one to try. Well, you know what? Let me do another one first, and then I'll give you one to try. Okay. Let's do this one. I'm taking these off the sheets, the chapter 6 practice sheets that I sent out. So it says rationalize the denominator, and the question is 7 over 9 minus radical 7. And again, we have this problem of having a binomial in the denominator, and there's a radical there. And therefore, we're going to multiply by the conjugate of the denominator. Remember, it's always the denominator that I'm concerned about. The numerator may turn out to be much more complicated, but simplified means denominator must be a rational number. So I'm going to multiply this by the conjugate of 9 minus radical 7, which is 9 plus radical 7. And whatever I do to the top denominator, I have to do to the numerator as well, so that I'm only multiplying by 1. Again, I like to do the denominator first. So 9 times 9 is 81. And radical 7 times radical 7 is 7. And a minus times a plus is minus. So this becomes 81 minus 7, which turns out to be 74. Okay, what about the numerator? Well, the numerator could either be written like this, 7 parentheses 9 plus radical 7. You could just write it with parentheses, not actually multiplying the 7. That is considered a correct answer. More likely is that we will actually do the multiplication, but don't forget when you're multiplying by the 7, you have to use the distributive property. So 9 times 7 is 63, and 7 times radical 7 is 7 radical 7, and that's all over 74. You could also do what I said before. You could separate it and write it as 63 over 74 plus 7 radical 7 over 74. If you wanted, these are all good answers. My preferable answer is this one, but you may see it in this format as the answer and this form. The reason I'm telling you all the possible formats your answer can take is because if you're doing a multiple choice test, then you want to know which of the answers, because they're only going to give you one of the correct answers, and they might be any one of these formats, and you have to realize that they're all correct. As I said, I like this format best, but this is also true, and this is also true. You ready to try it on your own? Any questions about that? Okay, so let's see if we can do a problem. Let me give you a problem for you to try on your own. I'll write the problem. I'll leave this on the board. I'll write the problem over here. This is, again, I want you to rationalize the denominator. The problem is square root of 3 over 2 minus square root of 3. See if you could rationalize this. I'm going to give you a couple of minutes to try it on your own. Let me erase this so that we have space to work this. And again, when I look at this problem, it's not the numerator that I'm concerned about, even though it has a radical in it. It's the denominator, it's the one on the bottom that is going to give us the problem, because again, if it says simplify or rationalize the denominator, we want to make sure that we aren't left with a radical in the denominator. So again, like I did before, since these are two terms, I'm going to multiply by the conjugate. Now the conjugate of 2 minus radical 3 is 2 plus radical 3. So I'm going to multiply the top and the bottom by 2 plus radical 3. Now again, as I said, I always like to do the denominator first. I don't know why, but I do. 2 times 2 gives me 4. Negative times positive is negative. Radical 3 times radical 3 is 3. And 4 minus 3 just gives me 1. What about the numerator? Well, now I'm going to have to use the distributive property. So I'm going to have to do the square root of 3 times 2, which is 2 radical 3. And the square root of 3 times 3, which is just plain 3, not in a radical, because when you multiply a radical by itself, it just removes the radical. So your answer comes out to be 2 radical 3 plus 3 over 1. When something's over 1, you could just write it without the denominator. Now, if you see it as 3 plus 2 radical 3, if they change the order, it doesn't make a difference. This is your answer. And I hope most people did get that answer. Okay. So now we're going to go on to the next topic. And the next topic is, look, what did we talk about? We started out by discussing radicals, what they mean. Then we showed how to simplify them. Then we added and subtracted them. And now we've learned how to multiply and divide. So now we're going to go to the next step. We're going to ask, how do we deal with a radical in an equation? How do we solve something called a radical equation? And what we're going to do is we're going to try a very simple equation and think it and see if we can figure out the answer. And from that simple equation, see if we can come up with a method for the more difficult ones. Okay, so I'm erasing this. And I'm going to look at an equation like this. What if I gave you the square root of x is equal to 9? Now what I'd like you to do is to think about the answer. I'm going to give you a couple of minutes and see if you could put the answer on the chat. If you have that ability, you can put the answer on the chat. See what you think the answer should be. Shouldn't take you too long to do. Okay. Nobody put any answer on the chat. Nobody came up with an answer. Anybody? Anybody want to say what they think their answer should be? Okay, I guess everybody wants me to do the work. I really think there could be. Oh, okay, Shireen came up with an answer, only Shireen. And Brenda Mendoza, I like those answers. And Jessica Asada, I like your answer, except I think you wrote 9 times 9, and I'd write you to write 81. A bunch of people are coming up with the answer 81. And actually that is the right answer. Because if you think about it, if you replace the x with 81, the square root of 81 is 9. Well, let's think how we got that answer. And it sort of goes in with how we actually do all sorts of equations. If I have an equation, let's say x plus 3, if I have 3 added to my x, what I want to do to get x alone is to subtract the 3. If I have 5x in my equation, then the way I'm going to get the x alone is, since x is being multiplied by 5, I'm going to do division. In other words, every time I want to undo what was happened before to get my x alone, I'm doing the opposite operation. Well, over here, the operation is the square root. So therefore, in order to get the answer, I should do the opposite operation, and that's squaring, multiplying by itself. Now let's see what happens when I square. Each side I'm going to square separately. So I'm going to do the square root of x times the square root of x on this side. But I know when I multiply the square root of x times itself, it just gives me x. And on this side, it's 9 times 9, which is 81. So that actually is the method that we use in solving a radical equation. We do the opposite operation of taking the square root, which is squaring, which is multiplying by itself. Notice, anytime you're multiplying a radical by itself, all it's giving you is what's inside the radical. It's removing the radical. So the side that has the radical in it, when I square it, just gives me the x. But the side that's not in the radical has to actually be multiplied out, 9 times 9, to give me my 81. So this actually gives us a method that we can use to solve radical equations. And here's basically the steps. If you have a radical in your equation, the first thing you're going to want to do is get the radical by itself. If there's anything outside there, get it by itself. And then square both sides to get rid of the radical. So if I have a question that looks like this, where I have the square root of 3x plus 4 equals 5. Then if I want to solve this radical equation, then what I'm going to do is I'm going to square both sides of the equation because I want to get rid of the radical. I square the side that has a radical in it. If I multiply the square root of 3x plus 4 by itself, it just gives me the 3x plus 4. The side that has the radical in it, when you square it, is really much easier to do because all it does is remove the radical. The other side you get by actually, that's not a radical, I actually have to multiply it out. 5 times 5 gives me 25. Don't forget, the side with the radical, you just remove the radical. The side without the radical has to actually be multiplied out. 5 times 5, 25. And now you have a regular equation. Bring the 4 to the other side. That gives you 3x equals 21. And divide by 3. And it gives you that x equals 7. It is extremely important that when you have radical equations that you check your answers. Let's check this answer by replacing x with 7. So this will be 3 times 7 plus 4, that's inside the radical, equal to 5. Now 3 times 7 is 21, and 21 plus 4 is 25. And the square root of 25 does equal 5. This makes sense. This is the correct answer. Okay, I'm going to do a couple of examples before I give you one to try. What if I gave you this example? I have the square root of 4x minus 7 plus 5 equals 2. Here is again a radical equation. I have the square root in my equation. But before I actually do this multiplying by itself, I want to make sure that the radical is all by itself. It's similar to when we solved our absolute value equations. We made sure that there was nothing outside the absolute value before we started breaking it up into two equations. When you have a radical equation, the first thing is to make sure the radical is isolated. So we want to get this 5 to the other side, which gives me that the square root of 4x minus 7 equals -3. And if I follow the rules that I gave you before, since I want to get rid of my radical, square both sides. Now, when we square out the side that has a radical, the square root of 4x minus 7 squared just gives me 4x minus 7. The -3 is not in a square root, so when I square it, -3 times -3 gives me 9. And now I have a regular equation to solve. So this gives me 4x equals 16. And that gives me x equals, when I divide both sides by 4, equal to 4. Okay, let's check our answer. Okay, to check an answer, I have to replace the x in my equation by 4. So this will be 4 times 4 minus 7 plus 5, that's on the outside of 5, equals 2. Now 4 times 4 is 16. And 16 minus 7 is 9. So this becomes the square root of 9 plus 5 equals 2. And I know the square root of 9 is 3, so I get 3 plus 5 equals 2. 3 plus 5 is 8. It's not equal to 2. This didn't come out right. What happened that when I did all the right steps, why didn't it work? Why didn't my answer check? Let's go back. Let's go back to this step over here. Okay, I'm erasing this and going back to the original step where I subtracted the 5 from both sides, and I got that the square root of 4x minus 7 equal to -3. And I should have stopped right here. If you recall, when we started talking about radicals, and when we started talking about square roots, if I write something like the square root of 36, the answer is always a positive number. The square root, I know that you could do -6 to -6 and get 36, but the square root, the radical sign is always what we call the principal square root. It's always positive. It has to be positive. So when I saw this thing that the square root of something is equal to -3, I know that's a false statement. The square root of 4x minus 7 can never be equal to -3. It can only equal a positive number. Well, if this is a false statement, there can be no solution to that problem. And that's why when we tried to solve it and check it, we didn't get a good check. That answer that I got was wrong. There is no solution to this problem. Therefore, I could have stopped right here as soon and not gone through all the extra work when it became obvious to me at this point, I should go no further because there can be no solution. So let's go through the steps again. When I have a radical equation, what we want to do is isolate the radical. Once we have the radical all by itself, make sure to look at this number and make sure this number is positive. We actually had to do that with absolute value equations as well. Otherwise, there's no solution. If this is a negative number, you can stop right there. There is no solution. Okay, let's see if I can give you a problem to try on your own. Actually, this is a problem from the practice sheet on chapter 6. Okay, so I'm going to give you one to try. See if you can do this problem. The square root of 2x minus 3 plus 4 equals 7. See if you can solve that equation. Give you a couple of minutes to try it on your own. Again, I have this radical with a +4. I want to get rid of the 4. I want to get the radical by itself. So I'm going to subtract 4 from both sides. This is going to give me the square root of 2x minus 3, equaling, this cancels out, 7 minus 4, which is 3. Now remember, before I go any further, I look at this number. Once I have the radical by itself, this number has to be a positive number. It is, so I can go further. Now I can square both sides. When I square the side that has the radical, that just removes the radical and gives me 2x minus 3. Over here, when I square it, the 3 is not in the radical, so I have to actually multiply it out. 3 times 3 is 9. And now I have a regular equation to solve. I add 3 to both sides, which gives me 2x equals 12, and divide by 2, and it gives me x equal to 6. Remember to check. Let's check. The square root of 2 times 6 minus 3 plus 4 equals 7. Always check in your original equation. Now 2 times 6 is 12. 12 minus 3 is 9. So this is the square root of 9 plus 4 equals 7. But we know the square root of 9 is 3, and 3 plus 4 is 7. So it does check. This is the correct answer. Again, don't forget to check radical equations. Okay, I want to do one more example before I end this session today. Let's say I gave you this problem. The square root of x plus 7 minus 5 equals x. Let's look at this problem. We're going to do these together. Again, I want to get my radical by itself, so I'm going to add 5 to both sides of this equation. So this will give me the square root of x plus 7 equals, this cancels out. Now these can't be combined, so I just have to keep them separate, x plus 5. And now that I have my radical by itself, now I can't tell if this is a positive number or not, so I have to go further. It's not like it's just plain 5 or just whatever. So I'm going to go further by squaring both sides. So when I square the square root of x plus 7 by itself, of course, that just gives me x plus 7. Again, whenever I have a radical and I multiply it by itself, it just gives me what's inside the radical. But when I square the other side, it's not in a radical, so I actually have to multiply the x plus 5 by itself. Now, what makes this more difficult is because this is a binomial and I have to use FOIL. So this stays the x plus 7, and this becomes x times x, which is x squared. Outer is 5x, and inner is also 5x. And last is 5 times 5, which is 25. In other words, we get that x plus 7 is equal to x squared plus 10x plus 25. And when I look at this equation, which is so much more complicated than what I started with, I see that it's a quadratic equation because it has an x squared in it. And therefore, I have to get it equal to 0 so I could solve it. Now it makes more sense to go this side way rather than this way. I'm going to subtract x from both sides, and I'm going to subtract 7 from both sides. So on this side, I'll get 0, and on this side, I'll get x squared. 10x minus x is 9x, and 25 minus 7 is 18. Okay, let's move over here, finish this up. I'm going to rewrite it. I'm going to write it as x squared plus 9x plus 18 equals 0. It doesn't matter. You could always switch it around. It just looks like more regular this way. And I know I want to factor this. Let's see if we can factor this. That'll give me x and x. The last term is positive, means they both have the same sign. The middle being positive means they're both positive. And I need numbers that multiply to 18 and add to 9. I think you'll all agree it's 6 and 3. And then remember, we separate them. X plus 6 equals 0. So one answer I get is x equals negative 6. And x plus 3 equal to 0 gives me x equals negative 3. I ended up with 2 answers. Do I stop right here? No. Because this is a radical equation, I've got to check. I've got to check my answers. Okay, which means I go to my original equation. Checking with negative 6 gives me negative 6 plus 7 minus 5 equals negative 6. That's the first check. I'm going to do a check of this one. Well, negative 6 plus 7 is 1. And the square root of 1 is just 1. So I have 1 minus 5 equals negative 6. And this is negative 4 on this side and negative 6 on this side. They're obviously not equal. This answer is no good. Let's try the other answer. Let's check the other answer. Let's check negative 3. That one gives me the square root of negative 3 plus 7 minus 5 equals negative 3. Now, this negative 3 plus 7 is 4, so this is the square root of 4 minus 5 equals negative 3, and the square root of 4 is 2, and 2 minus 5 is negative 3. This one checks. So in this case, x equals negative 3 is a correct answer. X minus 6 is what we call an extraneous root. The only solution to this question is x equals negative 3. And if this would have been a multiple choice question on a test, instead of doing all this work, which is a lot of work to solve it, sometimes it just makes sense to take the answers and check them. Because even after you've done all the work, you can't say, oh, I got the 2 right answers. It turns out that one of the answers was an extraneous root, and therefore we couldn't use the negative 6. We could only use the negative 3 answer. That's the only correct answer. Again, don't forget that this became so much more complicated because we had here an binomial that we had to square, so that we ended up with a quadratic equation. I think I'm going to stop right here. Let me just remind you to keep looking at